Welcome back, everybody. What is good? We are back with another episode where we're going to be solving some more logic problems. Let's dive right in. John, Aries, and Joseph are brothers with different ages. Who is the youngest if the following statements are all true? Aries is the oldest. Okay, the far right side will be oldest. Joseph is not the oldest. John is not the youngest. Well, if John's not the youngest, then he must be the middle. And then Joseph, who's not the oldest, must be the youngest. So, who is the youngest? Joseph is the youngest. Awesome. In the above image, a cube is painted so that each side is a different number. If each of the colors 1, 2, 3, 4, 5, and 6 are to be used, then what side is opposite the side colored 2? Okay, so here we have three different perspectives of a cube. We see sides 1, 2, and 3 here, sides 3, 4, and 5 here, and sides 2, 3, and 5 here. So what I'm first noticing is we never see side 6. Side 6 is always missing here. So where would side 6 be? Side 6 must then be opposite side 3. So it would be on the left face in perspective 1, it would be on the bottom face in perspective 2, and it would be in the rear face in perspective 3. What else is it asking? It's asking what is opposite the side colored 2. So what do we need to figure out? Here we know it has to be one of two things. It has to be 5 or it has to be 4. As we know where 1, 2, and 3 are, we know 6 is opposite, and it has to be 5 or 4 then. Those are the only two remaining in perspective 1. Well, I'm looking at perspective 3, and we see that 5 is adjacent to 2. So that means it must be 4. So 4, the orange face, is opposite to the blue face. Awesome. Great work. Let's see this problem. There is only one false statement in this list. There are only 2 false statements in this list. There are only 3 false statements in this list. Exactly how many false statements are in the list above? Okay, well, let's do some thinking. There is only one false statement in this list. Well, let's actually start at the bottom. There are only 3 false statements in this list. Okay, there's only 3 statements in general. So if this is a lie, and this is a lie, and this is a lie, could this be the case? There are 3 false statements in this list. Well, if this is false, then that means there's not 3 false statements. There would be only 1 or 2 false statements. If this is true, there are 3 false statements. Well, we don't have enough statements for this to work out, right? So statement 3 must be false. Statement 3 must be false. And again, that's because if it was true, if we take statement 3 to be true, there are 3 false statements in the list. Well, we only have 2 other statements. So statement 3 must be false. Okay? Let's work our way up. Let's look at the middle statement. There are only 2 false statements in the list. Okay, again, if we take this to be true, then we already know statement 3 is false. And if this is true, then statement 1 must be false. And what does statement 1 say? There is only one false statement in this list. Well, if this is false, this holds up. This holds up. We could have this arrangement. False, true, false. Exactly how many false statements are there in the list above? Okay, I'm thinking 2 right now. Now, I don't want to immediately check that answer. I want to think about, well, what if statement 2, we took it as true? What if we took it as false? We already know statement 3 is false. What if we say statement 2 is false? There are only 2 false statements in this list. If this is false, then the statement there is only one false statement in this list would also be false, because then all 3 would be false. But this cannot be the case, because then statement 3 would be true. So this is not possible. So again, statement 2, so from this, statement 2 must be true. And if statement 2 is true, there are only 2 false statements in the list, then statement 1 must be false. There is only one false statement in the list, and this is false because there's 2 false statements. So I'm going with choice 2. Excellent. These problems are kind of tricky. I definitely recommend going case by case. Even talking out loud to yourself, that's useful. Hearing the words out loud can sometimes lead you to the correct answer. Let's continue on. Assuming your opponent will play optimally from now on, where must you play next in order to obtain a winning position? And I'm assuming we are the X's, as X went first. Or no, we're the O's, right? Are we X's or O? You're playing tic-tac-toe with an opponent who is X while you play O. Okay, we're the O, and we want a winning position. Where must we play in order to obtain a winning position? So we want to have 2 winning opportunities. Okay, so where could we play in order to have 2 winning opportunities? Well, if we played in this corner, our opponent must play here to block us. And this is just going to result in a cat, so this isn't good. I would have to block him, they would then block me, I would block them, and then this is a cat. Or a tie. So let's think of the center. What if I play in the center next? Well, then they must play here to block. And then, where could I play? I could play in this corner to block O, but then they would win. So that's not good for me. Okay, so it's not the middle. What if I play in a corner? Which corner would I want? What if I play in this bottom corner? Then he must play here to block me. And then I play in the middle to block him. And then no matter what, they cannot stop me. They would either stop me in this corner, and then I would win this way, or they would stop me in this corner and I would win this way. So the bottom right hand, this spot would be a winning position. So we said no to the middle tile, either upper left corner or lower right corner. Okay, we should check the upper left corner, but this looks good. Either left side or lower side, either left side or lower side, or upper right corner. Upper right corner was a no. So let's check the upper left corner. If we play here, they must block us. And then where can we play to have 2 winning positions? Well, we have to play in the center to block their winning. And then again, we could either win this way or this way. So our answer is B. Awesome. Let's continue. In the figure, the figure shows 3 glasses filled with water and 3 empty glasses. With just your hands, what is the minimum number of glasses you have to pick up in order to make the bottom arrangement? Note, no sliding of glasses is allowed. You can pour the water from one glass to another. Alright, well that last sentence, you can pour the glass from one to another, is kind of seems key. Well look, we have these already line up, and the only one missing is here. So if we just take this glass that's filled and pour it into this glass, then it would be filled up and it would be empty here. So we only have to pick up this middle filled glass and pour it in here. So we're only picking up one glass. So is 1 our answer? Excellent. 1 was our answer. Alright guys, this was Challenge Quiz Level 1 for some logic problems. I hope you're enjoying this little logic series. I find logic problems to be really useful in just deciphering word problems. If you have trouble with word problems, I definitely recommend watching these logic videos. If you get a feel for them, you'll kind of see some strategies, and you'll just be all-around better test taker, and it will be great. So thanks so much for watching. If you have any advice for me, leave it down in the comments below. If you have some problems you'd like me to solve, let me know that in the comments below. Thanks for watching. Please subscribe if you haven't already. Until next time, take care.